starting. All attendees are in listen-only mode.
Good evening, everyone. This is Mr. Taylor with Young Engineers of Today. Hope everyone's having a fantastic Wednesday evening and had a great day today. If you can hear me, raise your hand. Okay. I see Evan, Brendan, Nathan, Sarah, Zach, George. Fantastic. Got a good mic here. Excellent. I'm going to put your hands down. If you can see my screen, raise your hand. Okay, we got George, Nathan, Evan, Zach. Hopefully Sam and Sarah can see the screen. All right. Remember, as we go through tonight, make sure if you have questions, raise your hand, or you can type in the chat box as well, which is always helpful too. Okay. All right. Now, before we get started into things, I just want to know if anyone experimented or tried anything out with their snap circuits over the past 48 hours that they'd like to share or talk about with the tonight. All right, I guess no one. All right, no big deal. Well, let's see here. Henry, thank you. I'm doing good. How are you? All right. Let's get moving. First off, please have your snap circuits near you. You're going to be using those tonight. Please let me know if you have your snap circuits. Type in a message that you have them so we're good to go. If you need to go get your snap circuits, please raise your hand. All right, Zach, go get your snap circuits. Henry has his. Brendan has his. Henry has his. Evan has his. All right, if you need to go get them, go get them. We're going to be using those tonight. Keep the books nearby. They might come in handy. All right. And someone asked about what a whistle chip was last time. A whistle chip is a snap circuit piece that allows you to do a little physical touching within a circuit, and it will change sound levels of different things. For example, we'll be using it tonight. Katie, no big deal. Just reviewing a little bit and getting started. Okay. All right. So let's rock and roll, as they say. All right. Just to review. Remember, electrical circuits are a lot like plumbing. Water flow, except the difference is water flows through a pipe and ends up in one direction, where this plumbing water would flow in a circle. And that's how circuits work, circles. This is how this helps us. And this flowing of this is actually our current in this case. Brendan has his hand raised. Yes, Brendan.
I added some stuff from my other snap circuits kit that we don't have in this one, like a solar panel and a little thingy that looks like a number that would be on a scoreboard.
Okay, what do you have, the green energy one?
I have all of the ones you gave me.
Okay, and what's the kit that you already had that you said you added into it?
I don't know what it's called. The box upstairs.
Okay, cool. And what did you do? Did you make anything pretty cool or sweet with it?
Yeah.
Nice.
But it didn't work.
All right, no big deal. Hey, if you never tried it, you would never known it didn't work.
So I'm not using the book. I'm trying to do it without the book.
Awesome. I love your enthusiasm, your creativity, and your science mind to hypothesize and create. Great job. Thank you, Brendan. All right. Okay. Our next slide, voltage. Voltage, as a review, is this pushing force of our current. We get, in this case, what we're using with our batteries, that's what's giving our voltage from those battery cells. And this, think of it as like water falling down a waterfall, because this gravity is the force pushing, okay? It pushes our current forward. All right. Last class, we also spoke about resistance. Resistance is the friction that impedes our current through a circuit. It gets in the way, it slows it down, our current, so the voltage isn't being as pushed as much. All right. Okay, so we talked about a little bit about resistance a little bit last class. Now, overall, this flowing is called our current. Our current is what's moving through, is the electrons moving through our wires. All right. Okay, so let's move into some new things. We're gonna start off with a few tips before we start using our snap circuit kits. Make sure if you are using a book in general, look over the directions. Make sure you're following those directions when you use a book. I'm going to have some screenshots up here that you're going to be using. Anytime you see the black numbers, that this tells you the order in which you're going to build pieces. Like this piece will come first or this piece will come second. All right. Furthermore, anytime before you turn on a switch or a button switch, and S1s, S2s, potentiometers in this case as well. Potentiometers are, if you have it in your snap circuit kit, they're a green triangle piece that has a slide switch that actually has a built-in resistor that will increase or decrease resistance. They're pretty cool. Check the connection, make sure everything's snapped together. When you're using different pieces, make sure they're snapped in, they're tight, they're where they need to be. All right. All right. And be careful when you're using fan motor is running. We don't got to get our face too close to things because sometimes that fan blade will shoot off. If it shoots off, you don't want to catch it in the eye or something like that. So just be careful. Not like these are real dangerous, but just little safety tips, etc. All right. All right, as we get going, well, we're going to be doing some parallel and series activities. So make sure you're following along. We're going to be going through the projects. Once again, the black numbers. Check for short circuits. Make sure everything, we're going to discuss your observations. You want to write anything down that comes to mind. So when we talk about it, you're more than welcome to. And let's have fun, all right? So let's get to building. All right. The first two things we're going to build. We're going to build two series circuits, one with a light, one with a fan. All right. If you want to experiment with using L1 or L2 or an LED in there, go ahead and try it. But go ahead and build these first two. If you understand my instructions, raise your hand. And then once you're done, just type a quick message in that you're done, and we'll talk about what the circuits did, how series circuits work, and so forth. All right, Brendan, Evan, Sarah, Taha, understand. Let's go. Let's do this. Good job, Evan. You're finished. Yes, Katie, do both. Taha's done, Henry's done, Evan's done. While other people are done, I'm going to call on some people to see what they did and how they worked and what they thought. All right. So let's go with Henry. Henry, you're unmuted. What took place there with the series circuit? What happened with the series circuits?
Well, they just, when I slid the switch, closed, the light turned on, and the fan went, like it started spinning.
All right. Now, awesome job. Thank you very much. Good. Thank you, Henry. All right, let's go with Evan. Go ahead, Evan.
Unmuted.
It just activated the things. And also, a couple hours ago, I just did 1 through 10, so I know what everything does in advance.
All right. Well, nice job. Okay. We'll be doing some other ones tonight as well. So, thank you. Okay, Evan. All right. Sarah's done. Katie's done. All right. So, what are some characteristics of series circuits? What do we know about series circuits? We just built two. We looked about it a little bit last class. What are some characteristics or some, and how, with that in mind, how does energy flow? All right. Let's go with Sarah. Sarah, go ahead.
Series circuits are kind of special because the energy goes in one direction.
Okay, good.
And so if and last on Monday you talked about how when you were a kid the Christmas lights were series, and if one went out you'd have to test every single one because they would all go out.
Yes, great job. Sarah, nice job. Thank you very much. Great answer. Anyone else like to give some input? All right. All right. So we know the energy flows in one direction. What I want you to do now, we're going to do a series circuit with the fan. And what I want you to notice is that the motor here is upside down. If we put the positive side backwards, where it's in the down direction, something special is going to happen with you guys. So try that one. And then after that, you're going to put a series circuit with a light and fan. I want you to take a look at the way the fan works and as well as the lamp in this, okay? If you understand my directions, raise your hand. Good. We got a lot of hands up. All right. Go ahead, and once you're done, let me know or type in what you think, as well as tell me when you're done. All right? Great job, everyone. Katie, how you doing? Katie, you're unmuted. Is everything going all right?
Oh, I didn't mean to raise my hand. I'm sorry.
All right, but how's everything going? Building those circuits?
Good.
All right.
Yes, sir.
Great job,
Wait,
Katie.
both again?
Build both. Build the top one and then build the second one. And what I want you to do is make observations about what you notice is different or similar. Okay? All right. Thank you, Katie. Nathan, try it. Turn the motor around. Let me know what happens. Make sure, everyone, you're building both. Yes, Brendan.
When the first time when I did it, or I mean the first fan I did was the regular one, and so when I turn it off, it fly up in the air. And the second time, the second one when it's flipped around, when I turn it on and then turn it off, it would not. I mean, the first one would fly up in the air when I turned it off, and the second one when it's flipped over,
Yes.
stop.
Awesome. Great observation. Did you do the second one now? The series
Yes.
circuit with light and fan?
Yeah, with the light and fan.
Yes.
Okay.
All right. Make sure you go ahead and do that one, and then let me know what happens there. Thank you, Brendan. Evan, see that you're done. I'm calling you. Evan, what happened with the series circuit with light and fan?
It turned the light off a bit, but if the fan wasn't there, it would light up.
Store.
It's new.
OS 10 update.
It does that all the time. But if you took the fan out, it would light up more, but the light is not shining much.
Okay, because where's all the energy going first?
It goes to the light first, and then it starts dying down and goes to the fan.
All right,
What
I want you to do is switch the motor in the lamp and see what happens. All right. Now, to those who are finishing, Nathan's hypothesis was correct. Awesome job. Katie says such a manly voice. Very nice. What I want you to do now is switch the lamp and motor and let me know what happens. If the lamp previously was getting dimmer, what do you think is going to happen to the motor? Is it going to go faster? Is it going to go slower? I mean, what do you guys think is going to happen? Katie thinks it's going to go slower. Evan thinks they're going to go the same. Try it. Yeah. All right. It's Zach has his hand up. Yeah, Zach.
Since the fan or the light was closer to the power source,
Yes.
the light lit up more, and the fan slowed down.
All right. What I want you to do now, Zach, since you're ahead of the game, and this goes out to everyone else, put 2 light bulbs before that fan and see what happens.
Okay.
All right. Very good. Thank you, Zach. Let's go with Katie. Katie, go ahead.
When I switched the motor and the light, my light turned on and it was bright, but then it went dimmer.
Okay. Now try this, Katie.
And the motor stayed the same.
Motor moved the same. Put your finger on the motor and keep it from moving and see what happens.
It's bright.
Why is it getting bright?
Because the motor uses more energy than the light does.
Exactly. So where are all the energy going to now if it's not going to the motor?
Now it's going to the light.
Awesome. Great job, Katie. Great job. All right. Let's call on Evan. Evan, go ahead.
Unmuted.
With the 2 light thing, the first light starts out really dim, then it dies, and the
Okay.
second light doesn't even get any electricity.
All right. So it's all being used up. How's the motor moving?
The same as usual.
Okay. Now, as I just told Katie, put your finger on the motor and keep it from moving.
they're starting to light up
Why?
because the motor doesn't need any energy.
Good. Excellent job, Evan. All right, let's go with Brendan. Brendan, you're unmuted.
Well, the same thing happened to mine. The first light was a little bit bright, not very much though. Then it got dimmer, but it still was still lighting up. And the second one got a little, like it barely glowed at all. Then it completely died, and the fan went slower. And I'm just about to try putting a battery on the other end.
All right, cool. Great discovery. Great experimentation. Nice job.
I'll have 2 batteries.
Okay, see what happens. You're doubling the voltage. All right, let's go with Taha. Taha, go ahead. Taha, you're unmuted. All right, we'll just mute you up there. All right, so we see that when you in a series circuit, as a series continues, a lot more energy is being used up. Raise your hand if you shot your fan blade up in the air. Anyone shoot their fan blade up? See Evan, Zach, wow, Nathan, wow, everyone. That's always fun to do. I always have a good time doing that. All right, seems like most people raise their hands. Okay, good. So actually, you guys did an awesome job and you answered my questions here. All right, let's move into some more series circuit. We're going to compare here a series circuit to a parallel circuit. All right. And if any of you are trying to do what some people want to do and experiment with double the power, be careful. You can try it, but you see like on the lamp where it says 2.5 volts, that is less than 2 AA batteries. Each AA battery is 1.5, so you get 3. Now, if you go ahead and put 4 AA batteries, you're going to have 6 volts. You're literally over doubling how much energy that bulb can handle. Same with motors and etc. What ends up happening, yeah, they get brighter, the motor moves faster, but eventually you're going to burn it out and overload that circuit, okay? So that's the reason we use resistors. And we'll be using resistors a little bit later. All right, or try 2 lights, etc. So go ahead and do these, and once you're done, raise your hands, okay? Brendan's using 2 lamps. Very cool. And a motor. Wow, making super circuits. Brendan.
Well, on the one I just did with 2 battery packs, what happened was the first light that came before the second was just regular. It looked regular. The second one was very dim, and the motor was very slow. But it was faster. It all more power than just one battery.
And what type of circuit was this? Series or parallel?
Series.
Okay, good. All right, great job. Thanks, Brendan. See, Evan's done. Henry just made one that uses Space Wars sounds and the motor. Cool experimentation. Anyone else want to go try that? That's pretty neat. Henry, was that a parallel or series circuit? Okay, project 5, the light pretty much stayed the same. All right. Go ahead. Katie, I would switch the motor and the light and see what happens. Oh, Henry did it in series. Okay, so you did it right in order. Henry, try to see if you can do it in parallel. Sarah. You're on.
I did them both, and in the series circuit, I could not get the fan to spin, but in the parallel circuit, it did spin.
Okay, because what is the major difference in the way the current is flowing, the energy in both of these?
Well, in the series circuits, it's going all the same way, and so the light takes up most of the energy because it comes first. I'm just guessing.
No, you are right. Good hypothesis. You are correct. Good job.
And then in the parallel, there's two possible ways for it to get through. So the light can't hog all the energy.
Good. Excellent job, Sarah. Great answer. You are long distance high five. Good job. Good job. All right. You guys are some awesome young engineers. Keep it up. Katie said same thing. It goes faster when I press the switch. All right. I'm done. And the light was dim. All right. Good job, Zach. Okay, great. I mean, you guys are coming up. Look at this. Let's get on one question. We're going to keep moving forward. If I stated that parallel circuit can give you more options, would you agree? Why or why not? Who would like to answer this for me? Any takers? Henry says depending. Let's go with Brendan. What do you think?
Well, a series circuit when it's flowing, it's not all in a circle, so it won't like one will not stop all the flow of energy. There's a big cord, and then like every cord kind of hands off the energy.
Okay.
And so if one of them just stops working, it'll keep going.
Okay.
Like the Christmas lights.
Good. Good. Anyone else like to share? Henry, I want to hear what you have to say. You're typing some stuff. Henry, what do you think here?
I think it depends on what you're using because, like, if you're only using a light bulb, it can't give you. Like, if you only have wire and a light bulb and, like, one battery, then you don't have more options. You have about the same.
Okay.
But, like, if you have more stuff, then yes, you can have more options.
All right, good. I like how you really analyzed the question. Good job, Henry. Good job. And I see you got your Space Invaders working. Zach says yes and more. Yes, because I can hold more power and there's two sides. All right. All right. Now, all right, we're going to do some more advanced parallel circuits. So let's do these next two. All right. All right, you're going to do a sound activated whistle chip. And someone asked, I think last class, about the whistle chip. It allows us to like physically interact. You can actually touch it and see what happens. And the second one, you're going to do a police light siren. So you're going to be using the IC chips. If you remember from last class, IC stands for integrated chips. These are pre-programmed. So like when you're making noise and music, and if you want to change them out to different ones, try it out. Experiment. All right. But if you understand what you're doing here, raise your hands. Oh, no. Sorry, I jumped ahead. Ignore what I just said. I literally skipped some slides here. I become Sir Click-a-Lot a little bit. All right, we did this. Okay, we talked about that. This is where we're at. We're going to do some advanced parallel circuits. All right. Sorry about that for the confusion. Please try these two. You're going to do a musical doorbell. That's the bottom one. And then you're going to two-speed fan and light. So you'll be able to change the speed. Yes, Evan.
Yes, unmuted.
I was just raising my hand for I get what I'm doing.
Okay, good. Sorry, I made that a little bit confusing because I clicked on the wrong slide. All right. Thank you. Katie.
If I'm correct, are we doing number 15?
Yeah, you're going to do a parallel circuit 14 and 15 here. Okay?
Okay. Okay.
Thank you. Sorry for the confusion. That's my fault. Oh, Henry states that his sister knows Katie. Henry, go ahead and do these, but try them and experiment as well, but integrate your experimentations into these two circuits. All right, Henry? Does that make sense? Okay, Katie, you have your hand up?
Oh, I didn't lower my hand. I'm sorry.
Oh, no problem. No big deal. Thank you. You're welcome. Yeah, Henry, just integrate those. You can try different things, but start off with those and then experiment from there. Henry, that's funny. You can't tell who's winning in your Space Wars battle. Very cool. Katie said number 14, the light didn't turn on after 5 seconds. You couldn't even see it. Very interesting, Brendan states. All right, Brendan, go ahead. You have your hand up.
Well, when I did the 14, I turned it on and the fan went on, but it went slow and the light was dim. And when I pressed the button, it turned off the light completely, but sped the fan up.
So what in that parallel circuit? What was it doing with the power then when you hit the button?
Blocking the one that went to the light.
Very good. So then
Directing it to the fan.
Nice job. Very cool. Great work on that. All right, keep it up. Everyone move on to number 15. You guys are doing an awesome job. Katie, it might be my my chair that's squeaking. My mic might be too good now. Raise your hand if you need more time with 14 and 15. Nathan, Katie, Evan, Brendan. All right, got a lot of hands up. All right, I'll give you guys, take your time. Yes, Katie, you have your hand up. Katie, go ahead.
Yeah, the resistor, what number is that? Because it blocks the number.
That is resistor.
So
It's the
R,
one. It's R 100 ohms. I think that's R1 or R2. It's 100 ohms on it. It'll have 100 on it.
Ask him if he'll pull up a drawing and draw the schematic of
will
it.
you pull up a drawing and...
Yes. Give me 1 second.
Okay. Can he draw a schematic?
Can you draw a
I'm
schematic?
pulling it up right now. I'm just literally waiting for my Word to open up.
Okay.
That is the R1. Katie, did you hear me? Here.
Yeah, I did.
this is what it is. R1. Okay.
Okay. So are you going to draw up a schematic?
I don't have a software to draw the schematic. This, can you see the image?
Okay.
This is an image directly from your
Yes.
books.
Okay. Thank you.
And the schematic I could make, it would make the same exact thing with these. This is the instructions to make a snap circuit schematic. I don't have a software.
Okay. Thank you.
Okay.
Yeah. My mom
Whoops, sorry.
wanted.
Go ahead, finish, Katie.
My mom wanted to know.
I wanted to know if you could do it.
Oh, she wanted to know if I could do it.
Yes. Do you want me to find? Does your mom want me to find you a schematic software that I could put on Edmodo? Or would you want to physically draw a schematic yourself? Well, I'm just curious.
Maybe after class.
Yeah, because I have had students use a schematic software before. If your mom wants to know that, I do have one. I can go look it up, and I can put it in there. And
Okay.
what it does, it gives you different schematic pieces, and then you could use them to make your snap circuits if you wanted to. Is that? Do you want that or no? Yes, maybe so.
Sure. Thank you.
Okay, you're welcome. Just trying to make sure I'm answering the questions correctly. All right, Evan.
The resistor on the speaker just makes it quieter.
Okay. What would happen if you used? What would happen if you used a higher resistor? Try like an R2 or R3 or R4. What do you
It'd probably make it really quiet.
All right, try it out. Let me know. Let's see if your hypothesis is correct. Katie, your hands up.
Oh, I forgot to put down my hand.
Oh, no problem. I just want to make
My
sure.
computer is slow.
Oh, no problem. No problem. Just want to make sure everything's okay. Does your mom have any more questions?
No. Thank you, though.
Oh, you're welcome. All right. Does anyone need any more time with this? Okay, Brendan raised his hand. And no one else. Let's give it about. Oh, nope, no one has their hand up now. All right. We explained the first. What is happening in the second pair and the musical doorbell? What is taking place there? Can someone explain this to me? What is happening in our second parallel circuit? Let's go with Evan. Evan, go ahead.
I'm muted. The switch is activating the doorbell, and then the button makes the arrow light up, making sure that it's working, and then the music makes the speaker sound it, and then the resistor just makes it quiet.
Okay,
My hypothesis was correct. I have to put my ear to the speaker to actually hear it.
Okay, good. So your hypothesis was correct. Awesome job. Do you think this would be easier or harder to do in a series circuit?
Way harder.
Way harder. Okay. Why?
Because it'd be hard to get all of this in one string, and because there wouldn't be a lot of power for everything to work.
Nice job. Thank you, Evan. Good.
You're welcome.
Let's go with Brendan. Keep your hand up.
When I did it exactly right, but only the light lit up and the thingy didn't make any music. And as Evan said, I put my ear up against it and I turned off the volume on my computer, and still I couldn't hear anything.
All right. What resistor are you using?
The R1.
Okay. Um, interesting. Well, what you can do is try to see if your speaker works on other things. Before you do that,
I tried some other. I tried some other experiments with the speaker.
did it
Of
work?
course, I just might have not done them right because I wasn't referring to the book, but the speaker has never worked.
Okay, maybe it's defected, which could be.
I have another speaker though. I have the exact same speaker in my other kit.
All right, try that speaker and find out if it works.
That one has worked in the past.
So then, probably a defected speaker. Good that you have a backup. Okay. Thank you, Brendan. All right. All right, good. Now, Katie, try a stronger resistor. Use the R1. Try an R2, then try an R3, and see what happens to the sound. Okay. Okay. All right, ladies and gentlemen, we have two more. We're gonna probably work on this evening. It's almost 7:20. All right. So we're gonna try two more. Okay. Now you're gonna be using a whistle chip here in the top one. In the bottom one, you're gonna be using two IC chips, U1 and U2. If you want, you can switch those out with other IC chips, and you're also gonna be using a photoresistor here. So basically, what I want you to do with the photoresistor and the second one is cover it and turn the slide switch on and off and see what happens when you have it covered or not covered. So it's when it's exposed to light or not exposed to light. So that's what you're going to be doing there. And as well as in this first one, close the slide switch, open the slide switch, and see what happens. And you can tap on the whistle chip. Okay, that's what you're going to be doing in this one. These are both parallel circuits. Nathan tried one of the last one with no resistor and said it was very loud, which is very true. Okay. All right. If you understand what you're doing here, raise your hand. Okay, Nathan here. And I like that you guys are experimenting. Yeah, build it, experiment, change things, make discoveries. All right. Engineer something that isn't there in these instructions after you do it. Okay? Very good. Okay, we had hands that go up to show they understand. Good job. Brendan, you have your hand raised.
Yes, the first time when I went to go get a new speaker and tried it again, it still did not work. The light has been lighting up at the speaker. I've not been hearing any sound.
I would go through and make sure you have everything connected correctly. Like that because a lot of times with snap circuits, they look like they're connected, but they're not snapped.
Okay.
All right, just double check on that because we might just have a short circuit. All right. Thank you. Way to keep problem solving. Good job, Brendan. All right, let's go with Evan.
The first one I realized that numbers 3 and 4 don't work. ICs don't work. Only 1 and 2 will for me.
Okay. Can you elaborate on that, please?
When I swap out the ICs, only number 1 and 2 will make sounds, and the 3 and 4 just say nothing. They do nothing.
Because a lot of times those also depend on how they're connected.
Mm-hmm.
To activate the tones or music or etc. what it's doing. Okay? So maybe try connecting to different parts of it, like in some of the previous ones. All right? Thanks, Evan.
Okay.
Katie said it's too loud. Katie, try a resistor and see if you can dim it down. The whistle chip allows you to interact with sounds, all right? And also within your manuals in the table of contents, it will explain every part that you have in your snap circuit kit. And it'll give you an explanation and also so you can relate it to real world items, similar to what we did last class, where we looked at a bunch of snap circuit parts. We looked at a schematic of the symbol as well as looked at pictures of what the real deal part of it looks like. Katie, you can go ahead and do 10 if you want. Yes, Sarah. Sarah, you're unmuted. All right, Sarah. All right, Katie, RP. Let me look for RP. There's SP. All right, I'm going to call on you, Katie. All right, right after I call on Sarah. Sarah, go ahead. Sarah, you're unmuted.
I put in some resistors.
Yeah.
And I put in 3 in different spaces.
Mm-hmm.
And when I put down the third one, it changed the siren from a fast siren to a slower siren.
Why do you think it made it slower?
Because the resistors are resisting the power like rocks in a river.
All right, good.
And so instead of letting the siren go faster, they made it slow down.
Very good.
Like water.
Nice job, Sarah. Excellent connection. Great. All right. Katie, I'm gonna mute you because I want to make sure RP. Katie, go ahead. You had a question about RP, I believe.
Yeah, what does it do?
I'm looking for it on here. Is it on our screen or? Oh, RP photoresistor. Photoresistor. What I want you to do in the circuit, if you can shine light on it, see what happens, and see if you can take away light. What would happen? Okay. Why you have the slide switch on or off? Okay.
Okay.
All right. Thank you, Katie.
Wait, what?
Oh, sorry. You had something else to say. Yes, Katie.
I
Katie.
put I was putting my stuff on, and then I found out that when I put U2 on, that I couldn't fit the speaker.
Do you have it spaced out correctly?
Yes.
All right. What you could do is just add some snap circuits to just connect it to it, like a two-piece,
Okay.
or build it out a little bit further. Does that make sense?
Yes.
Okay.
Thank you.
You're welcome. Let's go with Henry. Yes, Henry. You're unmuted. Henry? You're unmuted.
What is the unit UF?
UF? We want to see UF. All right.
Because it's on all, it's like on C1, C2, C3, C4, and C5.
All right. I'm going to slide this around. Tell me if you see what UF. All right. There's U8. You said it's on the C's? CO. UF. I'll have to look that up because let's have a logo. That is it's the units of which it's being measured in. And that is is that a capacitor? Give me 1 second, Henry. Make sure that's. Yes. You see this, Henry? It's a capacitor. The UF is the measurement of capacity
Okay.
it's being measured in. Kind of like how we measure amps and voltage, or ohms and
Yeah.
resistance. All right.
Yeah.
Okay.
Okay.
You're awesome. Let's go back to here. All right. All right. Well, everyone. 7:32. Let's answer a few questions. Get to a conclusion. Yes, Sarah. Oh, sorry, Sarah. Click on you again. Yes, Sarah. Go ahead.
When you cover the RP thing with your hand and it blocks the light, I think that the reason when you do that and the thing turns off is because the batteries don't give quite enough energy to power the whole thing, and then something inside, and they in the snap circuits they can turn the lights into energy.
Okay, good. Basically, what we're doing here with the whistle chip and the photoresistor, these are one of the first steps into using like sensors, which can lead you into like robotics. Photoresistor is measuring light, and it helps react with how much energy is moving through it. Now, this is a great step. So, in a few weeks at your labs, we're going to be working with the NXT robots, the Mindstorm. So, this is just a great little connection. Okay. Thank you, Sarah. Now, we had our 2 parallel circuits. They did some cool stuff with speakers. Next grid. All right. If anyone has any more questions or comments, we are finished for this evening. To those in Raleigh, you have your lab this weekend with Mr. Dubik. You're going to be doing some advanced snap circuit kits. Everyone have a great night. Unless you have a comment, question, have a good evening, everyone. And thank you for participating. You did a great job tonight. And as always, thank you for being part of Young Engineers of today. Yes, Henry. You too, Zach. Have a good evening.
Oh, I forgot to put down my hand.
Okay, no problem. All right, Henry. Thank you. Katie said the police are chasing her. Did you get her IC chip working? Henry made the whistle chip change the pitch. What is the first thing we're doing in the lab after Legos or with Legos? Brendan, I'm going to call on you because I want to make sure what you're asking. Brendan. Yes, Brendan.
I wasn't raising my hand.
I'm calling on you for clarification with your question.
Oh, I just said what is the first thing we'll be doing in the lab after Lego gears and stuff like that?
You're going to be working with the Lego NXTs in the future. You're going to be doing some advanced snap circuits. Are you in, Brendan, are you in Raleigh?
Yes.
So Saturday, you're going to do some advanced snap circuits. And I believe the next lab after that will be NXT. You'll be doing NXT for a few labs.
Okay.
Okay. All right. Have a great evening, Brendan. All right, everyone. Anyone else have any more questions? Katie, I'm glad you're really enjoying it. Good job. All right. If not, have a wonderful evening, everyone. And take care. See you on Monday.